Krzysztof Kozłowski will, he is Linux kernel development, and he will talk about peculiarities in his field, and also what it really takes to get your contribution accepted in the one of the greatest, biggest project, open source project. Następna prelekcja będzie w języku angielskim, więc Krzysztof Kozłowski powie o specyfice pracy z pisaniem programowania na kernel Linuxa. Także Krzysztof, the stage is yours.
Dzień dobry. Prezentacja będzie po angielsku, bo tak wszystkie robię, natomiast pytania można zadawać po angielsku lub po polsku pod koniec sesji. So I mentioned I'm Krzysztof Kozłowski, I work for Qualcomm, I'm a co-maintainer of the Linux kernel, I take care about 3 subsystems there. There's also C subsystem, device tree bindings, they are quite big. I also still maintain the memory control drivers and Samsung Exynos SoC architecture. I contributed a lot to the Linux kernel, basically since that 3.11. Each release has at least one of my commit. However, recently I'm mostly reading the code, so mostly maintaining it. The talk will be showing some basic things, like I will, for the purpose of this limited time, I will simplify quite a lot. So I will not show all the rules of the Linux kernel development, obviously, and whenever kind of you actually want to learn the rule or do your job, then please read the documentation in the Linux kernel. If you cannot find the rule describing how to do it, then you are on your own, and that's one of the problems of the peculiar stuff of the Linux kernel development, that we don't have everything documented. For the purpose of the presentation, I'll be showing some examples with the source code examples with the for space indentation, which is again not Linux kernel coding style, but it's only here. So what I'll be talking about, I will show a few numbers, few trivias. I will complain about coding style a bit, and then I will mention how we are doing it, what's the process if you want to ever contribute to the kernel development. So let's start with a few numbers. Linux kernel is not the biggest open source project. If you just clone the repository, it will be around 5 gigabytes. If you clone the Chromium project, you will have quite more. However, both have similar amount of commits. So both have around 1.4 million of commits. That's quite big. And we are developing pretty fast. So every 2 months, there's a new release of the Linux kernel. Such release has around 14,000 commits and around 1,300 of merge commits. So the main trunk branch is not rebased, therefore there's a lot of sort of branching and merging. There's around 2,300 individual contributors to each kernel release, which is kind of attributed to around 200 companies. These are not the same people on every release, so the people do change. So, for example, per year, this number might be closer to 5,000 or something. Because every release has around 300 newcomers. So every 2 months, there are 300 who contributed their first patch to the Linux kernel. And the difference was with the 7.0, because then there was like a 500 people, so first-time contributors. All the numbers are taken from the LWN statistics. We develop fast. Obviously, we make a lot of bugs. And there was a study kind of trying to identify how good we are in debugging, or rather removing the bugs and reviewing the code. So this study was looking whether the commits are pointing to other commits, so like they're fixing something introduced much earlier, not exactly to the actual bug reports. And this study said that on average, the bug was being fixed after 2 years. It's not exactly that the bug is living discovered for 2 years, obviously. And the oldest bug have 20 years. So this is a bit exaggerated. I mean, this is true, but a bit exaggerated because this 20 years ago, it's the first Git commit. So each Linux kernel release still fixes 15, 17 on average issues identified or attributed to the first commit in the Git history. This is not the first Linux release, because before Linux release, before Linux was maintained in BitKeeper, and only since 2.6.12 we use the Git. So there's a first commit called initial Git repository done 20 years ago, right? So when we say that some bugs have 20 years, it's basically they point to this commit, that this commit introduced code which caused, let's say, that was not the best, right? But it doesn't necessarily mean that someone was not working on a bug for 20 years, although this is also possible. We are quite organized in development way. So this is the concept of kind of hierarchical way and maintainers or sub-maintainers. So maintainer is someone who takes care about subsystem. Subsystem is a piece of Linux kernel, like some common functionality. could imagine as the drivers for I2C bus, drivers for SCSI or whatever, or drivers for other storage or networking drivers, right? And such sub-maintainers which take care about the subsystem, they have their own Git tree. So usually they have their own Git tree, although some people still manage patches not with Git, they manage the patches as patches with a system called Kilt. So maintainers usually review the code, and they take the patches, they apply them to their own Git tree, and then later send such code to their upstream maintainer, which could be Linus Torvalds or could be someone higher in the chain. And we have around 300 of such maintainer trees, so 300 separate Git trees, which take care about the source code, and then later send it to the Linus Torvalds. But we have obviously many more maintainers, because some of the subsystems have multiple maintainers, and there are some maintainers who don't have a Git tree. They kind of review only the code. They take care about too little things to take the code in, but they do perform the review. And why I'm mentioning it, because if you have more than 300 maintainers handling the code, then obviously you have more than 300 people with their own opinion. And there's nothing more different than, more important than discussion about the coding style, right? And the spaces and indentation. So still about this hierarchy, so we start from the root is Linus Torvalds. So he takes code via pull request or merge request from other maintainers. And such maintainers, for example, is the SOC maintainers, take care about all system on chips, GPIO subsystem, MMC subsystem, networking system, and many others. And they can have other sub-maintainers. So in the case, SOC maintainers group all of the SOCs. So obviously, they take from Qualcomm maintainers, NXP, and others. So let me complain now about the coding style. Because we do have a coding style, and there's a link here if you want to read it. It's quite traditional, written more than 25 or 30 years ago. But we also have the 300 maintainers, actually more than 300 maintainers. So obviously, we didn't agree on everything. And only in 2024, there is a consensus on how to write a multi-line comment in the C code. So before 2024, almost all kernel used that kind of comment. But networking file system, networking subsystem, which is huge subsystem in Linux kernel, a lot of drivers, a lot of networking code, use different opening of it. And only now they kind of agreed. If you ever contribute to the networking drivers or networking code, you will still see this other style of comments. Please don't change it, but use the new one, so the common to the entire kernel. So comments are obviously not that important stuff, but line wrapping is one of the most important topics. People kind of try to flame war each other. So when do you wrap lines when you write code? So consider some long code or function declaration, some comment. Like here, there are multiple arguments. Where should you wrap it? Where should you break the line? Well, the options are, for example, 80 characters, like old terminal, when you code without any frame buffer. 100 characters, more 120. So obviously, it depends whom you ask, right? Because we cannot use one style. So we have something called check patch. This is internal linter, and the check patch will complain around 100. Coding style says explicitly that preferred limit is 80, unless the code is more readable. And now some maintainers interpret it quite differently. So some say that you should wrap your lines around 100 because the tool tells you, and some say that you should wrap at 80 because the coding style prefers 80. Good luck figuring out with whom you are working with, but you should adjust to the maintainer style preference. More about the coding style came around 2023 with something called cleanup. This is something new in the C language, not in C language, but in Linux kernel, which uses the C. So briefly introducing it, we use traditional C. We use the plain C, which is actually the GNU dialect of ISO C11. This is very traditional style. And for example, we expect that all of the variable declarations are at the beginning of the scope. So you have a function like this. Then at the beginning, you say that these are the variables used there, like some integers, some pointer to struct bar, some whatever other counter I, and then go instructions, right? This is in every scope, first declarations, then code. Very readable. And then around 2023 came the cleanup stuff. Cleanup is a dedicated header which introduces a set of macros which brings something called scope-based cleanups. And scope-based cleanups are nothing else than something from C++, which are auto-pointers. So this is not nothing like garbage collector, but it's basically the resource will be freed the moment when the variable gets out of scope, which is a pretty neat function. And if you look at this like example how to use it, because you will see such code in the kernel. So the old code would be, allocation would look like this. We have a function, and we start with the declaration. There's some buffer. We can, this moment, also initialize it and allocate the memory. So kmalloc is to allocate the memory. Buffer is 500 bytes. You do some stuff, and then you free. K-free is the freeing of the resources, right? And now the cleanup explicitly asks that declaration of the variable must come with the constructor. So the moment you define this buffer, it has to be used with the kmalloc, always. This is not a problem yet, right? So the code would look like this. There's a declaration, buffer, there's this weird thing, __ free. This is this cleanup thingy. And there's a constructor kmalloc. And we don't free the memory, there's no k-free, because it will be cleaned up when the buffer disappears. But what if we don't know the size, and you cannot construct this moment, right? So the allocation of the size is coming, for example, from other resource. You could imagine code like this, right? There is a function, there's a buff size, and you get this buff size from the whatever resource, and only then you have to, how much you want to allocate. So the code with the cleanup would look like this. And this is the problem, because the declaration of the variable buff appears in the middle of the code. And this is like a huge offense for the Linux kernel developers, because it's obviously something pretty ugly to look at. And this is the problem of the coding style differences. So depends whom you ask. Some maintainers say it's not a problem, because this is like an exception of the rule. We still find it readable. This cleanup is useful. Some maintainers cannot handle it. Some maintainers cannot handle it, and they rewrite the code which they receive, and they introduce bugs, because if you split this declaration with this cleanup from the constructor, you might actually introduce a bug that, for example, it will be freed without being constructed. So networking subsystem disallowed it completely, so there's a written documentation that say don't use it. And this is fair, at least they documented it. I mean, it's very good that they documented it. So about the commits coding style, we also have a few other differences. So quite important thing for us is how the Git history looks like. And the most important thing how the Git history looks like is how the one-line subject looks. So if you do git log one line, you would get a lot of one-line commits, right? And people actually, kernel developers, look at this, and this should be quite informative, obvious, what's there deep in this commit. So we have a style. And the style is you use the subsystem name, colon, driver, colon, something, like a SOC Qualcomm, this is subsystem, driver will be SOC info, and the message adds SOC ID for some new processor from them. But this is only for some people. Some other people, maintainers, expect something else. They ask to have subsystem, driver name, and not a colon, but they want to have a dash. And they will complain, or they will change your code, obviously, right? So there is a crypto colon img hash dash or hyphen. Well, some expect the capital letters, so there is a difference here. So it should be starting, the subsystem should be with capital letter input. And some don't use the colons at all, they use the slashes, so this should be supposed to be subsystem. You have to mention drivers if you touch drivers, which didn't appear in any previous place, and then driver name. So clock source, drivers, and the driver name would be MMO. And how to figure out? You use the git log to understand what the subsystem was doing in the past, and based on this, you try to write the same, and of course, you make a mistake. Well, that happens. So this was end of the complaining about the style. Let me mention a few things about the process. Git was created for the Linux by Linus Torvalds, obviously, right? So we use the Git. However, we don't use anything like GitHub or GitLab or other forge. We do have centralized place where the Git is stored. This is kernel.org. But we kind of treat it as a way to exchange the code. But we don't have a one place like GitHub, like GitLab. And reasons for this are quite complex. These are things for the other talk. Simplifying, because we want things to be decentralized and vendor independent. So the benefit of our approach is that we are decentralized, obviously, right? We don't depend on one forge. If GitHub collapses, we don't care. If GitLab collapses, we don't care, right? So this is plus. Minus, we don't have single place. So there is no single forge for development, so how people actually should meet. And the solution for this, for us, was email. So the process for contributing to the Linux kernel is email-based. And there are nice benefits of it. because email is vendor independent. Tools are available everywhere. You can use whatever client you have. You cannot block it, right? I mean, it's kind of really reliable medium, except that it actually can be blocked, because if everyone is using Gmail or everyone is using Outlook, then what if emails from you are being marked as spam? Turns out that actually this is happening. So the emails from the kernel.org domain are being flagged as spam by Outlook. So basically, the maintainers cannot reach people using Outlook. And Outlook is used by many companies. So not like Outlook, maybe you don't use, but companies use Microsoft stuff, unfortunately. Gmail still works, but it can also stop working anytime. So our idea of being vendor independent doesn't live up to the conditions of the entire world that everyone centralizes around the free services. Another minus of not having a centralized Git forge means that we don't have a centralized place for continuous integration or continuous testing. So we do have CIs, so whatever centralized building, testing, booting targets, but they are distributed over different subsystems. And many maintainers have their own systems. They duplicate work, so this is obviously not a great thing to do. We also have something which are bots, which are run by some companies, and they do scan the maintainer trees, and they do scan the mailing list. So the mailing list is where all the emails are happening, and they do the scan, they take the code, and they they build it. And some people run their bots by their own, of course. And when they run the bots, they, of course, misconfigure them, and this is answer from a bot, this is real answer. AI bot review, which complained that the copyright year 2026 is in the future, and this was obviously this year. So back to the future. So let's speak about the contributing process now, how you would like to ever send a patch to the Linux kernel. So the canonical way is that you do some work with your local Git repository. So you clone Git Linux from the Git kernel org, you do some work, you git commit, rebase, testing, do like this. You prepare nice work in good organized commits. And then you should prepare patches. Patches are the format to send a textual representation of a commit, and Git supports it. I mean, there's a tool format patch that will create you some nice stuff. If you run it like this with the -4 cover letter, it will create 4 files, which you have to only edit the cover letter, and this 4 other files are the patches which coming from your Git commit. So then you are supposed to run the linter, which checks whether the patches make sense. Then you have to figure out to whom to send it. There is no centralized Git forge, right? But there is a centralized place which describes who maintainer is and who maintains which code. And this scripts get maintainer will give you the answer to whom to send your work. So this is nothing yet that fancy. And if you configured the SMTP in your Git config, then you just run the git send email to this people identified, and you send all of your work, and, well, kind of done, right? So just for comments. But now review happens. So there is no GitHub, there is no Git forge. So you will receive this review via emails. So first of all, you have to have your email client messaging system ready. And we are quite old school there. So obviously, if you ever top post, so you reply before the quote, this will be kind of, you will receive a nice comment. If you try sending HTML emails, they will even bounce. And if you don't wrap at 72, because the style of let's say the white space style is the most important thing in the world. So if you don't wrap your emails at 72, the people will also complain. And there is some nice guide about etiquette. If you ever want to contribute to Linux kernel, please read it. So such review will tell you, for example, that you have to change something in your code. And you will be preparing version 2 of your work. So Git also helps in this. You will rebase your patch set, change something, and you just run git format patch -4 -v2. This will create you the second version of your patch set, which you, again, run the check patch, get maintainers, and you send it. This is nothing difficult, right? This is nothing crazy. And if reviewers are happy, they will send you email with quotes like this. I mean, Chuck Norris will not send it anymore, but Arnold Schwarzenegger might send you an act by or reviewed by. These are formal, we call them tags or trailers, and they kind of acknowledge that they reviewed or acknowledge your code. What you are supposed to do with it, so because this will be coming on your email. So you should not miss it. And if you ever prepare next version of your code, like a v3, because some patches were okay, but some patches were not okay, then you should manually copy this and paste to applicable commits. like you edit the comment, the commit, amend the commit, and you should paste these things without making mistakes, please, especially with someone's name. And this is quite tedious process. I mean, this is really like a manual process, right? It's error prone. If you select not a full text, but let's say you forget the first name person or first character, that's obviously a mistake. And what stops you from faking it? Imagine that you didn't receive it as an email, but you added by yourself, right? And people did do it. I mean, they did fake such reviews. So only the public shame and eternal disgrace would be the reason why you would not fake it. So please don't fake it. But it's still tedious and ridiculous process if you think about this in the world of the automation and how the computers could do things for you. Therefore, you can ignore all the previous instructions. So please ignore them. And the current recommended way to do this everything with the Linux kernel is to use something called before. So before is a Python package. It was written by Konstantin from Linux Foundation. And it helps in this process a lot. And it helps in this kind of ridiculous things which we have there. It handles versioning of your work. It handles the cover letter and also kind of keeps track of your cover letter. You can run the get maintainers in case you forget. And you start with the before, as simple as you start before prep, name of your branch. Then you do your usual work. If you want to edit the cover letter, which describes why you are doing it, what you are doing is, you run before prep, edit cover. If you want to run the linter, so this I mentioned earlier, check patch, before prep, check. If you want to get the maintainers, so to whom to send the patch, before prep auto cc. And then you send, assuming that you have a SMTP configured in your git config. So, but this is still not yet huge progress. The big progress is that these trailers, these tags, can be taken automatically. So you don't have to anymore copy-paste them by your hand. So there's a much less chance of making mistake because you just run before trailers -u, and they will be updated automatically on the branch, on this branch which is used for before. If you ever need to send a new version of your code, so new patch set, the before will help you with this. It will actually already prepare a cover letter with kind of changelog. So then you edit the cover letter again, and there will be placeholder to say what changed in your work between V1 and V2. And then, of course, you gain before send. Well, there's a recommended guide from Inaro, which I would, if you ever want to do, please use it. There are many other guides how to contribute to Linux kernel, but most of them are predating before. So they basically use the old process, the error-prone process, so I would recommend others to switch to the before. Well, that was fast talk, thank you very much, and I still have around 5 minutes for questions.
So any questions? You can get free socks for questions.
Pytania mogą być po polsku, po angielsku, jak Państwu wygodnie.
Czy jest jakiś nowy proces w związku z narastającym AI-em and codingiem przez agenty? Czy też są dodane informacje, że kod został co-authored by CLUG or something lub coś takiego? Są jakieś nowe procesy w związku z tym, że mamy ekspansję tego?
Trochę tak, trochę nie. To znaczy, to jest temat, który jest dyskutowany i on był poruszony w grudniu zeszłego roku. Odpowiedź była taka, że Linux odpowiedział, że AI to jest tylko tool, taki jak inne toole. Wiele innych maintainerów uważa, że nie, bo AI daje niezwykle łatwy, niezwykle niski próg wejścia osobom, które w ogóle nic nie potrafią zrobić i wysyłają dowolnego slopa. Więc polityka teraz jest taka, że kontrybucje, które są AI, powinny mieć dodatkowy tag w komicie, nazwany assisted by. I to niby ma rozwiązać cały problem. W praktyce oczywiście nic nie rozwiązuje, bo tego nie musisz robić, tak? To znaczy, kto cię sprawdzi, tak? No i natomiast oczywiście są takie przypadki, że ludzie wysyłali takie slopy, no i potem wszystkich wkurzali, więc ten problem jest nierozwiązany i ten assisted by, tak? No to jest taka formułka.
Okej, ja może chyba nie dosłyszałem, ale czy dalej mogę wysyłać patche przez GitHuba, GitLaba, czy ten mail to jest taka jedyna super ścieżka i jeśli wyślę go przez GitHuba, to będę gorzej traktowany?
Nawet nie miałbyś szansy wysłać przez GitHuba, ponieważ jeśli jest repo Torvaldsa, czyli Linuxa na GitHubie, może się sklonować i ludzie wysyłają tam pull requesty, ale to jest taki, tam nikt tego nie czyta. To jeśli kiedyś zobaczysz sobie na GitHub Torvalds Linux, to tam ludzie po prostu, to jest takie przedszkole, tak? Nie ma szansy wysłać pull requesta, po prostu nikt go nie odbierze, bo nie ma takiej, nikt tam nie patrzy i tak dalej. Jedynie maile działają, czyli to jest jedyna metoda.
Okej, dziękuję, świetnie.
Nie wiem, czy tak świetnie, ale...
Jak to, że maile od kernel.org są blokowane przez Outlooka i Gmaila jest znane, to czemu te duże firmy nic z tym nie zrobią? Przecież to jest, kernel.org to jest raczej popularna i mająca markę strona, czy tam adres.
No cóż, tak, w Google pewnie pracuje 500 000 ludzi i do kogo się zwrócić, że twoje maile są blokowane. I Google kontrybuje do Linuxa bardzo dużo, no ale ci ludzie, którzy kontrybują, no to oni nie używają Gmaila, tylko używają Google'owego, jakiś google.com, tak? No i oni nie mają tego problemu, no i oni nie są od IT, oczywiście, tak? Więc IT, Linux Foundation strasznie marudzi na to i oni walczą mocno, żeby obchodzić filtry, bo te duże firmy, duże korporacje działają tak, że blokują całe sieci IP i się nie interesują tym, że ty zgłaszasz jakiś sprzeciw, że ja jestem tu człowiekiem, a nie botem, tak? Oni po prostu idą na, no, jeśli usługa jest za darmo, no to oczywiście nie może być wysokiej jakości.
Dobra, mamy czas na ostatnie pytanie.
Mnie interesuje, czy tutaj w tym procesie merge requestów, recenzji i tak dalej jest jakaś procedura testowania tego kodu, który przychodzi. Jak w ogóle się dzieje, że taki maintainer jest, tak? On ogarnia, co się dzieje tam w tym subsystemie, który on maintainuje, tak? Czy jak to się tam odmienia. No i teraz ja chcę dać jakąś pracę, tak? Tej osobie. Jak on teraz zweryfikuje, czy ta moja praca jest poprawna, czy ta moja łatka nie wprowadzi jakichś złych rzeczy, tak, koniec końców. On po prostu wie, tak?
On ufa. Zaufanie. Wiele botów testujących, co wspomniałem o tym CI, oni są połączone z faktycznym testowaniem, czyli jest usługa, czyli taki cały projekt Kernel CI, w którym wiele na przykład firm współuczestniczy i oni faktycznie testują na niektórych urządzeniach, na przykład armowych urządzeniach, czy embedowych urządzeniach, faktycznie testują bieżącego Nexta i niektóre patche. Intel ma wielką usługę, która zarówno kompiluje, ale również testuje na x86. Wiele ludzi ma swoje własne testowane maszyny. Natomiast oczywiście, jeśli ty wyślesz takiego patcha, no to tego nikt tego pewnie nie przetestuje od razu na liście, więc jest zaufanie, że ty to przetestowałeś. I natomiast jeśli teraz pytacie, czy jest szansa, że kod, który nie jest przetestowany, ląduje w kernelu? No oczywiście też tak, no, sam tak dużo wysłałem tego.
Dobra, nie mamy czasu na kolejne pytania, ale myślę, że Krzysztofa można jakoś złapać.
Jakby co można mnie złapać, będę jeszcze dzisiaj przez kilka godzin. Śmiało podejdźcie. Dziękuję.
Super, dzięki za prezentację.